This is Zubair Qureshi with a new video, and today in this video I'm going to show you how the Cisco ASA firewall works, and the overview of the Cisco firewall, and the traffic flow, how the traffic flows through the firewall, what's the preference level of the traffic, right? So for this I created this PowerPoint, and we'll go through this PowerPoint one by one, and I'll explain to you what this means. So let's begin, guys. And for the labs, I have this mm, EVNG lab setup. So I'll use this lab, and I'll configure along with that I will be explaining you the concepts of the ASA. Okay. So let's go through the points. So first of all, um, what you need to know is the history, brief history of the firewall, right? Of the Cisco firewall. So this Cisco firewall came into existence as the first name was Pix firewall, right? So this was named as Pix Cisco SA firewall, evolved from Cisco's first physical firewall appliance called the Cisco Pix. Okay, the Pix firewall was a firewall with limited VPN capabilities. Okay, it didn't had those many VPN like capabilities at that time, and then web-based VPNs, SSL VPNs, and we have become popular, right? The Pix firewall had the ability to provide remote access VPN capabilities using basic IPsec. So you can say the remote access using IPsec and PPTP type VPNs. Cisco acquired. Okay, what happened then is Cisco acquired this company, right? Mm, the company's name was Altiga. Okay, let me grab my pen. Okay. The name of the company was Altiga. Okay, okay. The name of the company was what? Altiga. The company name was Altiga, and they used to manufacture VPN concentrators. VPN concentrators, and that was the part which Pix was lacking, right? So what happened is, firstly, Cisco went on and they used to sell this Pix box separately and the VPN concentrator separately. Okay. Later on, what they did is in the early 2000s, I guess, they developed this new, they made this new box, right? Which had the capability of the Pix and the VPN concentrator, and this box was named as ASA. So this is the one that we use right now. And this ASA is like the first generation firewall, right? First gen firewall, that means it can do packet filtering based on IP, source and destination IP, and source and destination port, right? So this is the first gen firewall, and nowadays we are using the next gen firewalls. Next gen firewalls, these firewalls have the capability to do the layer 7 inspection, right? Layer 7 inspection. So they can do URL filtering, they can do IPS, they can do IDS, they can do what, ESA, email security appliances, they can do DLP, data loss prevention, right? So they can do multiple things. They can do monitoring. So yeah, those are named as some of the firewalls that are next gen are the Palo Alto, and you have the Checkpoint, right? And also you have the 40 gig, right? And also from Cisco now you have the FTD, that is called the Firepower Threat Defense, right? So that was a brief history of the Cisco ASA, how it evolved from this to that, right? So yeah, let me just grab my cursor. Okay, then the thing is, okay. So these points explain the same thing. The VPN based capability was not there. The ASA firewall is combination of the center and all. So then, okay. Now, when you get a firewall, right? The firewall, when you get it out of the box, right? The fresh piece. So the thing is this is so this firewall is actually in the routed mode when you get it uh, from the box, or get it out from the box. So what does routed mode mean? You have two modes in the Cisco ASA, right? It's one is routed and the other one is this can be also called L3, and the other one is the transparent. This is the L2 mode. Okay, so this is the L2 mode. And okay, now the L2 mode, right? So for the L2 mode, why do we need L2 and L3, right? You would just think, right? So the thing is, say you have what do you say, a switch in your company. So this, say this is your infrastructure inside the company. This is the L2 access switch, and this goes to multiple users, right? Users and devices, right? This goes to PCs. This goes to laptops, and this goes to servers, like that. And this is ultimately connected to a router or an L3 distribution switch. So any device that is an L3, right? So here in between you would have this, say, a subnet, right? You will have a subnet here in between, right? You might have a subnet. So that would be a slash 30 with having two IPs here, one and one here, right? Total of four, in which you have two usable IPs. So for example, now your company plans to deploy a firewall, and then you don't need to change, you don't want to change this setup, right? So if you get an L3 firewall here, then what you need to do is you need to have two subnets again, one here and one here, right? Because this these ports will be uh, uh, L3 mode, right? So they would need an IP address, and they should be in different subnets. So say you don't need that, and what you do is, for that, in that case, what you do is you get a firewall, right? You just delete this, okay? You get a firewall here, connected like this, and the firewall just slips in between as an L2, and the subnet remains the same. Okay, not the same, but then again you need a bigger subnet slash 29, because this firewall, this switches have SVIs, right? That's how they do the inter VLAN routing. Here you have VVIs, bridge virtual interface. So this firewall would also need an IP, VVI IP, right? From the same subnet. So that's why you use the transparent firewall, right? So that is why you use the transparent firewall, and the difference between routed mode and the so, and another difference between the routed mode and the transparent firewall is obviously the routed firewall would be capable of doing the routing, right? So it will be able to do RIP, OSPF, like any other routers, right? OSPF, even BGP, EIGRP, and also okay, RP. So let me just, this would be EIGRP, and also static routing, right? So this is one. So let's delete this, and I'll remove this also. And in L2 mode, you will not be able to do obviously routing, and you will not be able to do NATing. So that is the difference between the L2 and L3, right? So let's move on to the next points, and the next point would be, so we are here, right? L3. It has all the routing functionalities that a router has. It can run dynamic routing, because the difference between router and that it has is that the router forwards all the traffic. Okay, yeah. So also, say you have a router, right? You have a router and you have a firewall. So let's see what's the difference. So the thing is, uh, the basic difference would be, router knows two networks, right? So in his routing table he has two networks, say 10 0.0.0/8, and he knows about 192.168.1.0/24. And likewise, firewall also has a routing table, right? It also has the routing table if it's in L3 mode, and he knows both the interface, both the networks. Likewise, like the router knows. Okay, 1.0/24. But the basic difference is if a packet comes to the router and says the destination is from these two, what it will do is it will forward by default. So router by default will allow the through traffic, right? But in case of firewalls, the traffic that is trying to pass through the firewall is blocked by default. Everything. There are some exceptions. I'll tell you what are those. So that is the basic difference between a router and a firewall. Right? So let me delete all this. Fine. So what is the next point? Let me just delete all this. So let's move on to the next point, and that is the okay, this one. Besides designing IP address, okay. So likewise in the Cisco routers, you go onto the interface and configure the IP address, right? But in case of the firewalls, you have two additional parameters on the interface. I'll show you those. Okay, let's discuss the configuration, and as this configuration would control the flow of the traffic on the interface level. So let me move on to my this, and I'll open this. Okay, so here on the firewall you have three configuration on the face. The first one would be the IP address, right? IP address that you need in firewalls as well as in router. And second is so the command would be IP, same IP address, and then the address, right? And then the address, and then the subnet mask. So here you don't have any what do you say, ID. The firewall doesn't understand the reverse mask, the wildcard mask, right? So everything you will define is in subnet mask, even the ACLs, right? So second is called the nameif. Second configuration, important configuration, nameif. So nameif is required for the firewall to name the interfaces, right? Because in firewall you will not configure any interface based on the physical ID. It will be based on the name. So for example, you go to the interface and say name if inside, right? So this interface will be named as inside, and this inside key has a specialty, I'll tell you. So the thing is, if you go on to an interface and say name if outside, right? This outside keyword is not case sensitive. Okay, it's not case sensitive. Even though it preserves the case. Okay, this does preserve the case, uh, and I'll show you how it does that. So this is not case sensitive, so you can name it in any case, like small letters, and uppercase letters. But the word inside has a special existence, right? So when you say name if inside, right? Name if inside, there is another parameter that is called the security level. The third parameter is the security level. When you say inside, security level is by default set to 100, and anything apart from inside in any like format, right? I capital N capital S capital small I small, so anything, any combination, right? Small I capital N small S capital I, like this, the security level would be 100, SQ would be 100. And apart from this, if you have anything apart from inside, security level would be 0. So when you go and configure the name if as outside, right, the SQ would be 0. SQ would be 0. And also name if say DMZ SQ would be 0, right? So these are the three parameters that you need, right? IP, name if, right, and the SQ. And the SQ is ranges from 0 to 100, 100 being the most trusted. Okay. And one more thing, that the interface having the high security level, and from if there is a traffic going from that interface and going to a lower security level, say even 99, that is allowed. Okay, that is allowed. And the reverse from, say, from mm low to high is not allowed by default. So that is the case with the security levels. And the next point would be, so it has security level is the number of between 0 to 10. It controls traffic flow through the firewall. How does it control? It controls because the higher to low traffic is allowed and the low to high is not allowed. When you configure blank with the name, it sets the security automatically to, yeah, I told you that, except from the word inside, right? IP address, you configure it just like you would on a router. You do have the ability to skip the mask. Yeah, okay, that is another point, right? You do have the ability to skip the mask, right? For example, you go to the interface and say interface Ethernet 0, right? Ethernet 0, so 0, and you say IP address, you have an IP address from the class C, 192.168.1.20, right? And then you can specify the subnet mask, dot 0, or what you can do is you cannot just go and what, hit enter here. Okay, you need to hit enter here, and this will take the default mask of the class. So class C has a default mask of 24, and that's all. So you need to see what type of subnet you're using, and then you can just skip the what do you say, the subnet mask there. So that point is done. Next would be the traffic flow. Yeah, I said high security level to low security. By default, all traffic is allowed to flow from high security interface towards a low security interface, as long as the routing information is in place, obviously. Although all traffic is allowed to flow from high security level to low security level, only TCP and UDP traffic is inspected. Okay, what does that mean? Let's go here and let me delete this thing. Yeah. So inspection, what does that mean? So you just imagine we have a firewall here. So I have the, okay, let me open the, okay, this one, right? So I have a firewall here, right? This is my inside, so this is 100, this is my DMZ, this is 50, and this is my outside, this is 0. So any traffic that is TCP based or UDP based, right? By default, any traffic is allowed, even ICMP. Okay, so that is allowed, but only TCP and UDP will be inspected, right? Inspected means it will create a connection table. It will create this ASA is going to create a connection table once it sees. So, for example, you see R7, right? R7 has an IP of 192.168.1.25. So let's say I am going to do a traffic that is generated to port 80, and it will go to, this is the source IP, okay, source IP, and the destination IP would be which one? Say this R8, so this is 192.1.20.20.10. This is 10. So my source port would be random 365655, say something like this. And the destination port is 80. I'm doing an HTTP, right? HTTP uses TCP, port 80. So this traffic, right, when it goes outside, it will be allowed because of the security level, but then the return traffic, right, return traffic has to come back, and the return is from low to high. So it will be dropped if you don't have a connection table, and the connection table will create a reverse entry of the traffic that was initiated. So in this case, the entry would be like this: 20.10 port 80 going to 192.168.1.25 port 36565. uh, I'll show you this when we create when we will do the lab, right? So this will be the source, this will be the destination, reverse of this thing, right? So this will be created in the firewall so that the return traffic is allowed dynamically. For the ICMP, you will have to create ACL here to allow the reverse traffic, not the initiate. So if you initiate a traffic from here, from R7 and ICMP, right, say a ping, it will go out, but the return traffic will be blocked. So to allow that, you need an ACL, right? So you need an ACL. So I hope you understood this thing. Next would be what? So let me check my slides, right? So we are on fifth, yeah, this one. So inspection creates a return traffic in the connection table in the firewall. This allows the return traffic to come back. This is known as stateful inspection. Yeah. This is called the stateful firewall. Right? Low security level to high security. By default, all traffic is blocked from low security level interface towards a high security level interface. That is correct. If you want this traffic to work, you need to create an explicit policy on the low interface to allow this traffic. This is done by creating an ACL. That's what I said. When a packet hits a low security interface going towards a high security interface, it will check the connection table first. If there is no entry in the con table, it will check the ACL permit. If there is no permit entry, it will check the default behavior. Default behavior would be your next would be in this case would be your security level, and security level blocks the low to high, so the traffic will be blocked. So this is clear. I think I don't have to explain anything. If you want to want this traffic to, okay, fine, fine. And the next thing is, okay, I need to explain you one more thing, that is the through and the true traffic. So the firewall has two kinds of traffic, right? So one is that is passing, okay, let me grab my pen, fine. So one is that is passing from the firewall and going to the outside, right? This is called through traffic. This is called through traffic, and by default through traffic from low to high, from low to high is blocked, from high to low is allowed. That too should be an IP based packet and unicast. Okay, includes TCP, UDP, ICMP, but ICMP will not be inspected. Okay, it will not create a connection, but you need to create an ACL. This is through traffic. One is which is generated to the firewall interface. So this is called the true traffic. Okay, through traffic is controlled by ACL, but true traffic will not be controlled by ACL. Okay, true traffic, you can say, it can be used for management traffic, right? You want to manage this firewall, right? So true traffic is kind of telnet, SSH, and there is a GUI mode also that is used by ASDM. So that is your true traffic, and the true traffic by default is blocked. Only exceptions I see. So for the true traffic, you can use ping. Ping will be allowed to the firewall. So I'll configure this and I'll show you how it works, right? Let me just first delete this, close this, and go to the slide, right? What does my slide say? Okay, so next slide would be the same security level. Okay, default traffic I showed you. Same security level. I'll show you this in my uh, practicals, right? Traffic destination profile. That is the true traffic. Okay, let's begin the lab. So I have this lab. And this I have already configured. Let me see. Cancel this. I'll open R7. Let me check R7. Enable show IP interface brief. This should be, yeah, this is 25, and this is configured. All are configured uh, apart from the firewall, right? Enable show IP interface brief. This should be 10. This is 10, and it has a default route. Show IP route. If you see, it will have a default static route pointing towards the firewall interface. So I have to configure the firewall, right? So all the interface on the firewall would have .100. So like the router, you go to the configuration mode, and then I'll change the host name ASA, and then write command, and then I'll go to the interface, that is the inside one, right? The Ethernet 0. I'll go to the interface, and I will type the IP address. So I can hit enter because it's /24, right? Class C. And then you have to specify the name. If now just check, when I hit enter after giving the inside name, if it will take the security level as 100 by default. See, security level for inside set to 100 by default. So that's what I said inside as a special um, characteristic, right? So and then I'll do the no shut, and then exit, and then I'll go to the next interface, that is Ethernet 1 IP address 172.16.1.100, and I need the, what do you say, the mask here, because this is class B. Okay, then the name if, and this is DMZ, and the security level will be 0 by default. Then I have to give the security level. I'll keep this security level to 50, and then no shut, right? And then exit, and then interface, I'll go to the Ethernet 2, right? 2 IP address would be 192.1.20.100, and enter, right? And then the name it is outside. So security level I'll keep as 0 only, and then no shut command. So no shutdown, exit. So if for the, okay, in routers, how do you check the interfaces? Show IP interface brief, right? But here it's show interface IP brief. Slight difference, right? Slight variation. You can see all the three interfaces that we configured right now, and also there is another command, show name if, that will show you the configuration for the name if, right? What names you have and the security level, and there is another command, show IP address. This is like the name if command with the subnet mask also, and method it will show it's DHCP or it's a static one. So this is three commands for the verification point. So next what we need is, let's go to R7 and ping the interface. Let's see the two traffic, right? ICMP I said is allowed by default 1.100, right? So this is allowed, right? Two traffic to the firewall. But if I try to ping, okay, do I have a default route? Show IP route. Yeah, I have a default route towards the ASA. So if I try to ping 192.1.20.10, say that the router ping is not successful. Why? I told you, inside to outside, you can see the router is receiving the packet, right? But it will be blocked by the firewall. If I turn on the logging on logging console logging console 7, so I'll uh, undebug all here, okay, and I'll try to ping again. So you will see here it will be blocked. Deny inbound ICMP outside is from 20.10, and destination is this type code 0 yeah, type 0 and code 0, that is the echo reply, that is blocked. So in case you want to I told you, right? Through traffic is controlled by ACL. Hmm? So if you want to allow this traffic, if you want this ping to happen, you have to create an ACL access list, in name that ACL, right? And then permit the type of traffic ICMP. I want to put permit only, that this should be specific, right? And the host address 192.1.20.10, right? going to host which one, 192.168.1.25. That is the ACL, right? And that it is only for what? Echo reply. Done. Echo reply. So I'll just disable the no logging on, no logging console 7. Sorry, no logging console 7. So I have show access list. So I have the access list, right? Yeah, that's the access list extended ACL. But I have to apply this. So apply this by the access group command. Access group. Then you have to the enter the name of the ACL, that is the in, and then the direction inside, interface outside. Here it's getting denied on the outside interface. So we need an access list on the outside interface, allowing that ICMP reply packet, right? So now if I try, it should work, right? This is working. So if I see show IP access list here, so show access list, I think. Hmm? Yeah, you can see the hit count, right? Hit count is 1. So just now, if I see again, this hit count is going to increase, right? You can see. So that ACL is working now, right? So this is the through traffic, right? But then again, is I told you that the let's remove this. Okay, let's remove the no access group in in interface outside. Okay, and you can see now it will not be working, right? So that's done. Now you can see what I'll do is I'll allow telnet and I'll allow HTTP on this router, outside router. So this would be HTTP enable HTTP server IP HTTP server. Okay, okay, done. IP HTTP secure server. So done. And okay, now what I'll do is from inside I'll HTTP to this 1.20.10 on the port of 80. That is the HTTP. So this is a TCP connection, and there should be inspection, and the reverse traffic should be allowed by default, right? So open done. You can see here by typing the command show connections, right? So you can see the reverse traffic I told you, right? So the traffic is generated from 192.168.1.25 to 192.1.20.10, right? The reverse is 192.1.20.10 80 going to 192.168.1.25 42818. That has been created inside the ASA. That's why the return traffic is allowed by default, by like dynamically, because of the connection table, right? So that is called the stateful firewall, and this is because of the connection table and the TCP and UDP getting inspected, right? But ICMP is not getting inspected. For that, we need an ACL, right? So we have done this, right? And next part is the same security level, right? So what I'll do is, okay, I need to test the the HTTP right as well. So that would be 443, and that would also be open, and you can check with the command of show con. You can see now 443 is also there, right? So that is done, and after that what I'll do is I'll go to the interface Ethernet 2, and I'll keep the security level as 50. So now, okay, before doing that, what I'll do is security level 0, right? So from low, from high to low, right? From 50 to this, it should work, right? So I'll go to uh, this, and I'll ping from VPC 6. From VPC 6, I need to ping which one? 1 to 20, this one. So for that I'll need what ACL, right? Allowing access list in permit ICMP host 192.1.20.10 going to host 172.16.1.25 echo reply. So access group access group what in access group in interface, this would be outside. Okay, fine. So now I'll try the ping again. It should work. Okay, let me check what is the problem. Okay, this is working. Actually, the IP address was wrong. I was pinging 25, and for the 25 we don't have any access list, but for the 10 I have created access list. So this is working, right? So this is going from lower to higher. Now what I want to demonstrate is the same security level. So I'll go to interface Ethernet 2, right, and set the security level exactly to match the DMZ. Done. So now this traffic will not be allowed. This because by default the same security traffic is not allowed, right? Even though you have an ACL, right? So ACL will not help in that case. So what you need to do is, in this case, you need to go this is a global command, right? Same security traffic permit enter interface. This is the command. Once you enter this and you try the ping again, and it's working. So by default, same security level interfaces will not talk to each other unless you give this command. And once you give this command, all the interfaces that are in the same security level will be able to communicate to each other. Okay. So that being said, next topic would be, okay. So we have done this same security level, right? I demonstrated the same thing. Now traffic distance to the firewall. So this is also called the management traffic, right? So let's enable the firewall to be telnetted from inside, right? Okay, to traffic is destined to an interface on the firewall. It is controlled by the service running on the firewall. ACLs will not have any effect on the traffic flow, right? That's what I said. By default, the only service that is running on the firewall is the ICMP, right? Because we can ping the interface file of the what do you say, the firewall that is uh, running ICMP, right? Ping. The only traffic that is allowed to successfully reach the firewall is ICMP. No other traffic is allowed to the firewall. Enabling or disabling of service on the firewall with per interface characters. So let's enable telnet on the inside. Let's enable telnet on the inside interface of the firewall. So that is done by going into global configuration and say telnet, and the IP address, range of IP address that you want to allow, 192.168.1.0. You see, the thing is, you can allow it to a particular host, but I'll allow this to the whole subnet, and then you have to specify the interface. So here you specify which interface you are enabling telnet and what all subnet range will be able to telnet. That's done, and then you set the password. I'll set a Cisco 123. Okay, that's done. That's done. That's it. Now you go to R7, and you telnet to 192.168.1.100. And open Cisco 123. Yeah, I'm inside the firewall. Enable Cisco 123. So I'm inside the firewall. Show interface IP brief. So this is the two traffic, and two traffic is controlled by enabling the services on it. So for this you also have, I told you, SSH and ESDM. So this is the overview and the lab for the initial configuration of the firewall. So guys, that's it for this video, and I'll see you in the next video, and I'll try to record the videos as soon as possible. Okay guys, bye bye, thank you. Please do subscribe to my channel and like my videos. Thanks.